Hey you guys, I'm Justin. My lab partner Brendan just went through the physical pneumatic circuit that we have over here. I'm gonna go ahead and show you guys what we have on paper. So the first thing that he was talking about in the beginning of that video was that we were given a Boolean expression to build the circuit off of. This was our Boolean expression given. AC not D, or BCD, or not ACD, or not BCD. And now this expression, if you see this big chunk right here, I wrote comments on the side. We went through and just wrote the generic expression one more time and began simplifying it. And what we did was we used the distributive property to grab the B's, the not B and the B together. We used the complement property to be able to turn that into a 1, and absorption, the 1 is obviously absorbed. 1 times 1 is anything, or 1 times anything is itself. And then from there we have the distributive law, where we put the not D and the D together, very similar to what we were doing with the B and not B up here, and we end up getting C and then A or D. And through the absorption law, we can further unsimplify that CA and CD. And the reason why I say further unsimplify is because this has 4 digits versus 3 digits, so it's a little bit longer, and that's what made us go with this as our simplified equation, C, and then in parentheses A or D. And from here, we applied this to our truth table with this as well, compared them together, and they matched up. So that's how we know we're on the right page here. And if we go through our truth table and actually look it out, we see the very first thing is that if we have C and D active, that's going to turn on the output no matter what. The reason for this is because we have AC right here without D. So as long as AC is active, we got it, and we got all of these are just different combinations, right? So then the next combination we have is the BCD, and then that's there, right there. And then of course we have C and then A or D, so it's gonna work for a simplified function as well. Let's go down the chart a little bit farther. For this one, we got ABC. Now this one was a little bit confusing to me at first, because if you look up here, there's not really an A and a B together anywhere, but the reason why this one is actually accurate is because all you need is C and A. B is kind of irrelevant. The fact that C and A are both active will turn on the output. And then the same thing with the last answer. After that, we went through with our logic function and we drew the circuit before we built it, and this was the drawing that we came up with. We had a couple rough drafts before this, but essentially it's everything that you saw with the physical copy that Brendan was showing you. We have our PSI source right here. You're gonna see it's gonna go into our first push button C, and it's the very first thing it does. Nothing's gonna even happen unless this push button gets pushed down. Once this gets pushed down, we have our OR function between push button A and push button D, and from here all you gotta do is push one of them. If you push both, it'll still work, but all you gotta do is push one. So let's say we push button D, it's gonna go through all the way up here to this, and this is gonna help stabilize the pressure here for it to be able to push into here. Otherwise, this was actually the bug that Brendan was talking about. It'll just come right down here and right out this way, instead of actually locking here and pushing into this. But yeah, so then after that, it pushes into here, and we get our cylinder extension and retraction once you lift up on the button. The reason why we have these connected together too is because if you remember from the physical circuit earlier, we spliced our pressure source from the beginning. So these are actually connected from the same source. And that is all of our stuff for this lab. There's some of the rough drafts. Well, thank you guys so much for watching the video. I hope you enjoyed it, and that was our lab.